Morning, grade 10s. Okay, we're probably going to do these videos in short little spurts. I'm having trouble uploading anything sort of longer than 8 minutes. So we're going to start at the end of the unit actually, and then we're going to go back to 4.1. Because this is a bit of a review of grade 9, so I think that'll get you back in the saddle. So we're going to talk about exponent laws, and we learned of quite a few of them in grade 9. And so the first part of these notes is just going to be a review. Okay, so if we were talking about the power, and that's what this whole thing is called, the power is the 3x to the exponent 6. So we're talking about a numerical coefficient out in front, and actually the power is just x raised to the exponent 6. So the numerical coefficient is the number 3, okay, and numerical means number, so that should be easy to remember. Sometimes you'll hear the x referred to as the literal coefficient, but in this case we're going to call it the base, and then the exponent is 6. So the entire thing is called the power, okay? This is the base, this is the exponent. All right, so let's jump into our exponent laws that we should remember. Product of powers. So product means when we're multiplying. And so you might remember from grade 9, when we multiply bases that are the same, we simply add the exponents. So we keep the same base, and negative 10 plus 15 is 5. Okay, and then if we have bases that are not numbers, and that's okay, these bases are the same, they're y. So we're going to add the exponents, and we're going to get 7. And here now we're going to get x, and then we're going to add negative 7 and positive 3, and we're going to get negative 4. Now, we should remember from grade 9 that we are not going to have a negative exponent. So I'm going to jump ahead, even though it's on the next page, okay, and see if you remember that when we have a negative exponent, we write the reciprocal of the base. So everything's really over 1. So this would be 1 over x, and then the exponent becomes a positive 4. Now that might be something you don't remember, okay? So we'll come back to it on the next page. Now here, okay, this is part of the polynomial unit and part of the exponent unit all rolled into one. We need to multiply these numerical coefficients. This is a 4 times a 3, so we get a 12. Now we write down the base, and now we add the exponents, because only the y's are being raised to the exponent. So if we have 11 minus 5, we have 6, and that's our final answer. Now these ones look a little weird, but they're not. They're not scary at all. We can see that the 2/3 are exactly the same, so we actually have like bases. So we're going to write down 2/3, and because it started in brackets, we're going to leave it in brackets. And now we're going to go back and we're going to add the exponents, and 14 minus 4 is 10. Okay, so now we're moving on to the next one. Quotient just means when we're dividing. So when we multiply, we add the exponents. You might remember from grade 9, when we divide, we subtract the exponents. So bases are the same, and 12 minus 9 is 3, and that's our final answer. And now we set it up here, and now I gave my grade 9s last year a little bit of a hint, so we didn't have to deal with the negative exponent. And Mr. Anholt taught me this years and years ago, and it stuck with me when I was in grade 9. If we have bases that are the same, okay, we pick where the exponent's larger. So you can see here, x to the power of 11, or the exponent 11, is larger. So he would tell us, leave the exponent on the bottom and subtract from there. And then you don't have to deal with the whole flipping it, right? You get a positive exponent right away. So that's one way to do it. Okay, now here, this is a nice example of when we are subtracting negatives. So if we have a y to the exponent negative 3 divided by a y to the exponent negative 9, when we subtract a negative, you got to remember we get that positive in there. So we end up with a negative 3 plus 5, so that ends up to be y squared. Okay, same thing happens here. We're going to subtract the negative 3, we get a positive, and we end up with 2 to the power of 7, because 4 plus 3 is 7. Same thing happens here. We're going to subtract a negative 3 and get a positive, and we end up with 3 squared. Okay, so go back and look those over if you don't remember. This is another exponent law that we would have learned in grade 9. Okay, power of a power. So when we have a bracket, we have an exponent, and then immediately outside the bracket, another exponent. Now we multiply those exponents. So we're going to get 2, and then negative 5 times 10 is negative 50. And now we have a negative exponent, so we get to practice this. We're going to write the reciprocal of the base. That just means the flip, if you don't remember that. And then the exponent becomes positive. So 1 over 2 to the power of 50. Okay, here, 3 times 6 is 18. Here we have x, and then 4 times negative 5 is negative 20. No negative exponents. We're getting a lot of practice, right? The reciprocal of that, and make the exponent positive. Now here it looks like we're going to run into trouble, but we don't, because we have a negative times a negative. We get a positive 12. Now this one looks ugly, but don't let it get to you. Here's the base. Rewrite it and put it in brackets. A negative 14 times a negative 2 is a positive 28. We're not solving these. We're just like working on our exponent laws. Okay, we're going to try and get through two more here. Power of a product. So there's a product in here. We are multiplying in there. That means this exponent goes to this piece here, and it also goes to this piece. So it looks like this. X to the negative 20, y to the power of positive 8. Now this positive 8 is okay, but that negative 20 is not okay. So we're going to leave the y to the power of 8 in the numerator, and we're going to write the reciprocal of this. In this case, it just means we're going to move it to the denominator where it becomes positive. So this might be something that you didn't have a whole lot of practice with in grade 9, okay? And let me know, and then I'll help you out. This has three pieces that are being multiplied. That means this exponent needs to be distributed 3 times. 3 to the power of 24, 7 to the power of negative 6, 5 to the power of 18. Now, these two pieces have positive exponents, and you got to remember that everything really has that invisible 1 as a denominator. So we're going to leave that 3 to the power of 24. We're going to leave that 5 to the power of 18, and we're simply going to move this 7 to the power of negative 6 to the bottom, where it becomes positive. Bingo. Okay, now this one here you should remember from the polynomial unit. We need to cube the 2. Then we need to cube the x to the negative 2. Then we need to cube the y to the 4. So 2 cubed. You can either write it as 2 cubed, or I would write it as 8, because 2 times 2 times 2 is 8. Then we get x to the negative 6, y to the power of positive 12. Now, the only thing that we need to worry about is this piece right here. We're not going to have negative exponents. Remember that there's sort of that invisible 1 denominator. 8 is okay. Y to the power of 12 is okay. We're going to make this a positive exponent by moving it to the denominator where it becomes positive. Okay, so now we're going to do the power of a quotient, and that just means that we have a division question, and then we have a set of brackets, so this goes to here, and it also goes to here. So x to the power of 16, we're going to multiply y to the power of negative 4. That's not okay. It's currently in the denominator. How are we going to make this exponent positive? Moving it to its opposite location, numerator. X to the power of 16, y to the power of 4. Let's do one more, and then I'm going to upload the video. Okay, so we have a negative exponent. Two ways we could do this question. Okay, we could distribute that negative 2 exponent to both pieces and then flip it, or we could flip it now, okay, because we have a negative exponent, okay, and we'll come back to this. So I'm just going to go with what you know right now, which is 6 to the negative 8, and then over 5 to the negative 14, okay? And so we know that in the numerator, this has a negative exponent, so we will move that to the denominator where it becomes positive. The same thing happens here with a 5 to the negative 14. We're going to take that upstairs, I like to call it, and it becomes positive. Okay, I'm going to stop the video there. I want you to take a look at that, and we'll come back and we'll finish up these initial notes, which are a review.